Today we're going to talk about area and perimeter of parallelograms. And we'll start with the perimeter. And the thing about parallelograms is that opposite sides of parallelograms are congruent. And once we know that they're congruent, that means they have the same length. We can use this to help us find the perimeter of any parallelogram. Because when we're finding the perimeter of a parallelogram, or any figure, we're finding the distance around it, the distance outside of the figure, meaning that we will find the sum. We add them all together, the sum of the lengths of the sides of the figure. When we do this, we need to go back to how are we going to find the distance. And so we're going to use the Pythagorean theorem. I'm going to use the Pythagorean theorem to find the length of a side. And once we find the lengths of the sides, we add them all up. So we take a look at the first example here. Again, we're going to find the perimeter. The nice thing is that opposite sides are congruent. So once we find the length of this, we know what the length of that is. Once we find the length of this, we know what the length of that is. So we can start by drawing in a triangle. We're finding the perimeter of the rectangle. And what we see is 1, 2, distance of 2. 1, 2, distance of 2. And we're using the Pythagorean theorem, and what we end up with is 2 squared plus 2 squared equals c squared. Well, that gives us 4 plus 4 equals c squared. 4 plus 4 is 8 equals c squared. And to solve this, we're going to take the square root of both sides. And we end up with c equals, well, on a calculator, square root of 8. And feel free to use decimals. When we round it, 2.82 becomes 2.8. That's not the only side. But the thing is, what we found now is that this length is 2.8 and this length is 2.8. Well, we need to find one more side. So we're going to draw in our triangle. By the way, you could have done the other two sides. It doesn't make any difference. But what we have here is we have 1, 2, 3. And we have 1, 2, 3. And we're going to set up Pythagorean theorem again. So 3 squared plus 3 squared equals c squared. 3 squared is 9 plus 9 equals c squared. 9 plus 9 is 18 equals c squared. And when we take the square root of both sides, again, use decimals, use your calculator. Square root of 18 gives us 4.24. Remember, we're looking at the 4 to determine what to do to the 2. But since it's 4 or less, we're going to leave it as 4.2. So now that we know that, that means that this length is 4.2 and this length is 4.2. And we can finish by finding the perimeter and all that we need to do. We're going to add 2.8 plus 4.2 plus 2.8 plus 4.2. Again, use decimals, use your calculator. 2.8 plus 4.2 plus 2.8 plus 4.2 and we end up with our perimeter is 14 units. Next, we're going to move on to a rhombus. And remember, with regard to a rhombus, all four sides of any rhombus are congruent. So we can use this to help us find the perimeter. And the nice part about this is, again, this length, this length, this length, and this length are all the same. So we only have to do one triangle. And it doesn't matter which one you choose. I'll look here to find the length of WZ, but it all goes back to the Pythagorean theorem. 1, 2, 3, 4. 1, 2, 3. And we set it up. 4 squared plus 3 squared equals c squared. 4 squared is 16. 3 squared is 9. 16 plus 9 is 25 equals c squared. And then when we take the square root of both sides, again, type it into decimals, type it into your calculator, so we get 5. But remember, the rhombus has 4 congruent sides. So when we want to find the perimeter, we're going to add 5 plus 5 plus 5 plus 5. We get 20 units. So there's the basics of perimeter. As we flip our paper over, let's look at area. In area of parallelograms, the formula is base times height. When finding the area of a parallelogram, any side of the parallelogram can be a base. The height of the parallelogram is the perpendicular distance between any two parallel bases. And then the area of the parallelogram, again, is base times height. So if we take a look at our first example here, it says find the perimeter and the area of the parallelogram. Round your answers to the nearest tenth if necessary. So the nice thing is on this one is we have everything we need. Once again, parallelograms. Opposite sides are congruent. That means that this length here is 20 and this length here is 10. And if we want to find the perimeter, we add up the distance of the outside lengths. 10 plus 20 plus 10 plus 20, and we get 60 inches. Again, type it into decimals, type it into your calculator if you need to. To find the area, well, the formula for area is base times height. Our height in this problem is 8. So our base here is 20. This is going to be 20 times 8, and 20 times 8 is 160. Remember, area is measured in square units. If you need to, type that into your calculator. Type it into decimals, whichever works for you. Once again, we want to find the perimeter and the area of the parallelogram below. We don't have everything in this particular parallelogram that we need. We're going to have to figure it out. The first thing that I notice is that the 45 degrees in this lower right hand corner can be used to help, but what we have to remember is that opposite angles are equal. So hard for me to get that 45 in, but here it's 45. It looks like a 6, and I don't know if I can fix it or not. 45. Try one more time. There's 45. Now, we do have enough information to figure out what the perimeter is, because once again, opposite sides are congruent. So this is 30 because its opposite side is 30. This is 15 because its opposite side is 15. So as we look at the perimeter here, it's going to be 15 plus 30 plus 15 plus 30. And type it in your calculator if you need to get the 90. To find the area, though, what we know in this particular problem is we know the base. We do not know the height yet, but we can find it by going back and using our trig functions. So if we take a look and label this, across from the right angle is the hypotenuse. Across from the 45 is the opposite, which happens to be the height, which is what we're looking for. Opposite, try for the h again, which means that this side here is the adjacent. Looking specifically at that triangle, and I'm going to change colors here just to show it. Maybe I am. Just looking at this triangle here. And the board's a little bit disoriented. But if we want to find the area, we want to find the opposite. We know the hypotenuse. And if you think back, the relationship that we're going to have to use is going to have to be the sine. Again, we want to know the opposite. We know the hypotenuse. So this is going to be sine of 45 equals h, or whatever letter you want to call it, divided by 15. And then we're going to do 15 times the sine of 45 equals h. I'm using my calculator today, but if you happen to use Desmos, remember, whenever you open up Desmos, you have to change it to degrees instead of radians, is what it comes up as. But my calculator, I think I better check. Oh, mine's in radians here as well, so I'll change it over here to degrees. But 15 times the sine of 45 gives us our value here, and we're going to round it to the nearest tenth. It's 10.60, so it's going to remain 10.6. So our height is 10.6. And now that we know that information, again, area is base times height. So our base is 30. Our height is this value that we just found, the 10.6. And we can type that in our calculator. 30 times 10.6. Again, feel free to use Desmos. And what we end up with is we end up with 318. Area is measured in square units. No. Find the area of the rectangle below. Round your answer to the nearest tenth. Well, it's a rectangle. That's the nice part here. So a couple things we know, but one of the things that we know is that this is a right angle right there. And we only have to find the area on this one. So this is base times height. We know the base. It's 19. We need to find the height. And the way that we can find the height is we can use the Pythagorean theorem. We know two sides. We don't know any angles here. In fact, we know the hypotenuse. We get 19 squared plus h squared for height equals 25 squared. If you don't like using the h, use x, use n, use a or b. It's not going to make any difference. And if we type that in here, 19 squared is 361. Plus h squared equals 25 squared, which is 625. And now we can solve. Subtract 361 from both sides. And 5 minus 1 is 4, 12 minus 6 is 6, and 5 minus 3 is 2. I think it's 264. And then lastly here, we need to take the square root of both sides. And this is going to give us our height of our rectangle. Square root of 264 gives us 16.2. And now we have everything that we need. We have the base. This is the height. So when we fill this back in, we're going to take 19 and we're going to multiply it by 16.2. And again, use Desmos if you prefer. 19 times 16.2 gives us 307.8. It's area, so we're going to measure it in square units, which is feet squared this time. 307.8. So it's all a matter of being able to identify the base, the height, knowing the characteristics of parallelograms. But as we get close to finishing here, it says find the base of the rectangle below using the given height and area. So now we know the area, but yet again, let me remind you that the area is base times height. So if we fill in the area, in this case it's 32, we know the height. It says find the base. We don't know the base, but we know the height. We want to find the base. Well, it's b multiplied by 4. We can undo the multiplication by dividing by 4. And we get b equals 8 inches. Finally, the quadrilateral below is a rectangle. Find the area and the perimeter. The thing that we need to remember about rectangles is that there's 4 right angles in there. But we also need to figure out what is the length. OMG. What is the length we've got 1, 2, 3, 4, 5, 6, 7. And 1, 2, 3, 4, 5, 6, 7. We're going to use Pythagorean theorem to find the length. And the thing is, the length of this is going to be the same as the length of that. 7 squared plus 7 squared equals c squared. Pythagorean theorem again. Well, 49 plus 49 equals c squared. 49 plus 49 is 98 equals c squared. And we want to take the square root of both sides. So type it into Desmos, type it into the calculator. The square root of 98 is 9.89. So we're going to say 9.9. We're looking at the 9 to determine what to do to the 8. Since 9 is 5 or higher, we're going to round that up to 9.9. But we also need to find the length of another side here. Here's our triangle, and recall that this length is going to be the same as that length for our perimeter. It's also going to help us with the area. But what we've got is we've got 1, 2, 3, and 1, 2, 3. So we've got 3 squared plus 3 squared equals c squared. Well, 9 plus 9 equals c squared. 18 equals c squared. And if we take the square root of both sides, typing in the decimals, typing it into the calculator, the square root of 18 is 4.24. Because it's 4 or less is going to keep that 2 the same, so this is going to be 4.2. And now that we have that information here, to find the perimeter, the distance around, we're going to take 9.9 plus 4.2 plus 9.9 plus 4.2, and we'll type that in. 9.9 plus 4.2, 9.9 plus 4.2 gives us 28.2 units. The thing is, even though the orientation of this is weird, this is a rectangle, and a rectangle has 4 right angles. And if you go back to the definition of the height, it's the perpendicular distance between the 2 parallel sides. So when we want to find the area of this figure, once again, the area is base times height, and I'm going to call our base 9.9. And our height, I'm going to call 4.2. And we're going to multiply these two together. 9.9 times 4.2 gives us 41.58. When we round here, we're looking at the 8 to determine what to do to the 5. Since 8 is 5 or higher, I'm going to round that and call it 41.6. Units.